So, when you're scrolling online, maybe right after a big earthquake hits the news, and you see these just bizarre video
So those
clips.
with the sky lighting up.
Exactly. The sky is just flashing with these intense blue or green or even purple lights, and it's happening like seconds before the big shake.
Right. And for years, I think the common reaction was, that can't be real.
Totally.
It was always dismissed as power lines snapping or transformers exploding, something man-made.
Right. A symptom of the earthquake, not a prelude to it. But our deep dive today, it confirms something pretty wild and honestly a little frightening.
That these lights are absolutely real.
They are. They even have a name, earthquake lights or equals. And they are a genuine atmospheric phenomenon.
A phenomenon linked to massive tectonic stress. So our mission today is really to get past the viral videos and unpack the actual science.
Okay.
How does the Earth literally flash, emit visible light right before a tremor?
And I think what's so important to get from the start is that this isn't some new thing,
Yeah.
It's not just from the age of smartphones.
Oh, not at all. The sources are clear on this. Equals have been documented for centuries.
Centuries.
Yeah, in historical records, often linked to the most powerful earthquakes in history. So this is a recurring thing that we're only just now getting the tools to properly analyze.
So this historical context proves it isn't just, anecdotal.
No, not at all. These are real lights, and they're clearly associated with very powerful seismic events.
So let's set the scene a bit. The anatomy of one of these flashes, it's just such a shocking visual because it goes against everything we think an earthquake is.
It does. You expect the ground to shake, you expect noise.
They don't expect the light show in the sky first.
And that's the unnerving part, isn't it? The timing. The lights usually appear right before the most intense shaking starts.
Before.
Yeah. You might get the first little tremor, the P wave, then the sky lights up, and then the destructive S wave hits. So the fact that the sky reacts first, it just raises this huge question. What is happening deep underground that is powerful enough to light up the atmosphere?
It's like the ultimate geological warning sign. Okay, so if they're real and they're happening before the main event, we have to talk about the science.
Right.
What are the current theories? Because this is where it gets really interesting.
Well, there are three main theories right now, and they aren't necessarily, mutually exclusive. They all center on the incredible stress and friction happening when the Earth's crust is about to break.
Okay, let's unpack them. What's the first one?
Yeah.
The pressure cooker idea.
Exactly. This is the one that's been studied the most. It's sometimes called the pole hole theory.
Deal what?
It stands for positive hole. The idea is that certain types of rock, especially igneous ones like granite,
Okay.
when you put them under immense, intense pressure, they start to release positive electrical charges.
Wait, how does just squeezing a rock make it electric?
It's all about the crystal structure. So inside these rocks, you have chemical bonds, peroxy bonds. When the stress gets high enough, these bonds fracture.
Ah.
And when they break, they release these mobile, positively charged holes. They're basically charge carriers.
So the rock itself is fundamentally changing. It's not just cracking. Its chemistry is shifting and creating this massive electrical potential.
That's a perfect way to put it. The crust essentially becomes a huge semiconductor, and the fault line acts like a superhighway for these charges.
And they race upwards through all the cracks and fissures.
Exactly. They shoot towards the surface, and when this massive wave of positive charge hits the atmosphere,
That's when you get the spark.
a giant spark, it ionizes the air, it strips electrons from the nitrogen and oxygen molecules, and that sudden huge discharge is what we see as a flash of light.
Which brings us to that analogy from the source material that the Earth is literally shining before it, metaphorically explodes.
It is. It's a release of pent-up energy from a system that is about to fail catastrophically. But that's just one theory.
So if that one is about static charge building up inside the rock, what's theory 2? This one is about rising plasma, right?
It is, yeah. So this theory shifts the focus from a cold static charge to actual superheated material escaping the ground.
And for anyone listening, plasma is that fourth state of matter, like what's inside a neon sign or on the sun. Super hot, supercharged.
Exactly. So this hypothesis suggests that the incredible pressure and heat deep in the crust doesn't just create a charge, it actually creates pockets of plasma.
Okay.
And the deep fissures in the Earth act like little vents, allowing this hot, charged plasma to rush to the surface and basically erupt into the lower atmosphere.
So instead of a spark from a traveling charge, This is like a mini eruption of glowing, energized gas itself.
A different delivery mechanism, yeah. The light would be coming from the hot material itself, not just from the effect it has on the air.
Okay, so that's two. What of the third one? This is about the friction between
Yeah.
the plates themselves.
Right. Theory 3 is more mechanical, in a way. It suggests the light is a direct result of the massive electrical discharge from the friction of the plates grinding past each other.
But the plates are miles deep, aren't they?
They are, which is where this gets debated. But the
Yeah.
idea is that the speed and force of two continental plates sliding is so immense,
Yeah.
it generates a colossal electromagnetic wave, a pulse that travels upwards at nearly the speed of light and causes the discharge in the atmosphere. It's less about a slow buildup and more about the instantaneous, violent moment of the rupture itself.
So whether it's stressed rock, rising plasma, or pure friction, the bottom line is that mechanical stress is being converted into visible light.
That's the common thread. Extreme stress leading to a very visible, very powerful energy release.
Let's pivot to those visuals, because that's
Yeah.
what really grabs you. The sources mention specific colors: purple, deep blue, green. It's what makes it all so frightening.
And the colors are actually the easiest part to explain. It's pure physics. It all depends on what molecules in the atmosphere are getting hit with that blast of energy.
Right, because different elements glow with different colors when you zap them with electricity.
Exactly. So our atmosphere is almost 80% nitrogen. When nitrogen molecules get excited, they tend to emit light in the blue and purple parts of the spectrum.
Which are the most common colors reported for equals?
They are. The green that's sometimes seen is usually from excited oxygen molecules. It's a very direct relationship.
It sounds a lot like the aurora borealis, the northern lights.
It's the exact same principle. It's external energy exciting atmospheric gases. The source material draws that comparison very clearly.
But it's different.
Very different. The energy source for the aurora is the solar wind, which is a relatively gentle, constant stream of particles.
Right.
For equals, the energy source is the Earth's crust suddenly failing. So the event is incredibly fast, it's violent, and it's extremely localized right above the fault line.
So it's an aurora born from planetary violence, not solar wind.
A very good way to put it. And that intensity is why the lights can be so bright and appear in these strange shapes, flickering ribbons, or even glowing spheres.
Okay, which brings us to the big question, right? This so what for everyone listening. Can we actually use this? Can this be a reliable warning system?
That is the absolute holy grail of this research. The potential is, it's immense.
So what's the dream scenario?
The dream is establishing a repeatable link. If we can prove that the light appears, say, 30 seconds or a minute before the major shaking in a predictable way,
Yeah.
we could build a terrifyingly accurate early warning system. Imagine sensors that detect the atmospheric flash and automatically trigger alerts, shut down gas lines, stop trains.
That window, even if it's just seconds, could save so many lives.
It would be the difference between people being caught completely off guard and having just enough time to duck and cover.
But there has to be a catch. Why aren't we doing this already?
Because the current reality is, well, it's complicated. The phenomenon is still mysterious in many ways, and the biggest problem is it's rare.
Rare. Even with big earthquakes.
Yes, not all major earthquakes produce equals. We don't fully understand why some fault lines and some types of rock seem to generate them while others don't.
Ah.
So until we can reliably predict when and where the lights will appear, we can't really rely on them as a predictive tool. Right now, it's an extraordinary observation, not a reliable instrument.
So we have this incredible potential tool, but we just need a lot more data to figure out how to use it.
We need to translate the language. We can see the signal, but we don't fully understand the grammar yet.
This has been absolutely fascinating. So to kind of synthesize all this,
Mm-hmm.
the Earth's crust, when it's stressed to its breaking point, it basically acts like a massive battery.
A highly charged one, yes.
And these lights are the final violent discharge of that energy, shooting from deep in the ground all the way into the sky.
It really changes how you think about the ground beneath your feet, doesn't it? It proves the planet's mechanics can literally bleed over into the electromagnetic spectrum.
And I just love the final piece of advice from the sources. It's so simple. If you're somewhere and you suddenly see the sky flash with these crazy, unearthly colors, and there's no thunderstorm,
Don't just stand there and marvel at it.
don't pull out your phone to record it. You should run. You should take immediate action.
Because the Earth is giving you a very clear, a very brief warning.
It's screaming, get ready.
Yeah.
Something big is coming.
Exactly.
Which, it leaves me with this one final thought for everyone to chew on. If pressurized rocks, miles underground, can create a violent light show we can see with our own eyes. What other more subtle warnings might the planet be giving us?
Mm.
Tiny shifts in gravity or magnetic fields or weird chemical signals that we just haven't learned how to interpret yet. Maybe earthquake lights are just the loudest warning in a whole chorus of signals that we're only just beginning to hear.